Hi everyone. So like I said in the introduction, we're going to be working on probability this unit. Often what I'm going to ask you to do is just follow along with some notes, which I will also have posted on our assignment sheet. And then I'll have you finish some of the worksheets on your own. So it will feel a lot different than some of the work we've been doing so far. Remember that when we're talking about probability, we're talking about basically the chance that an event occurs. And probability can be any value between 0 and 1. 0 being that an event is completely unlikely to happen, and 1 being that an event is totally certain to happen. A probability of 1/2 means that you have equal chance of happening versus not happening. So if I say what's the probability of getting a heads when you flip a coin, that's a probability of 1/2. So if you ever get a probability answer that's below 0 or above 1, you know that you've done something wrong. First thing I want to talk about is what does it mean for events to be mutually exclusive? So this means that the two events have no outcomes in common. So notice that that's this first phrase right here. The two events have no outcomes in common. Mutually exclusive events, we're going to go through lots of different examples. The idea is just there's no overlap at all. The events can't happen at the same time. Okay, so we're going to take a look at that with this first example. You've got a bunch of names here: kids taking math, kids taking science, kids taking reading. You may see some overlap as you see that. You see that math and science have some overlap. You may see a few other names that overlap as well. So we're going to do this by looking at a Venn diagram. Those are going to be one of the most important tools that we'll have throughout this unit. So in the left oval, we're going to write the first initial of all the students taking only math. So students taking only math. Well, Alice doesn't go in there. Bob does because he is taking only math. Alice, the reason I didn't put her in there is because she's taking science and math. Calvin is taking only math, and Elizabeth is taking only math. I'm excluding David because he's also in science. Okay, so this is the math only. And the other one, I'm going to put the people who are only taking science. So Alice is out and David are out because they're also taking math. But Frank is in, and George is in, and Helen is in, and Ivan and Jane. Now in the middle, I'm going to put the people who are taking both science and math. That would be the two people we just mentioned, Alice and David. So as we look at this Venn diagram, if I take the events as being picking a student who takes math and the other event being picking a student who takes science, because there is overlap, these two events are not mutually exclusive. So we would say no, because some elements are in the middle. In other words, if it is possible for both events to happen simultaneously, taking math, taking science, the events are not mutually exclusive. They are not completely separate events. In this case, Alice and David are the ones that are taking both. Okay, we're going to try that again with another case. So let's take a look at reading. So in the left oval, we're going to put the first initial of all the students taking only reading. So this oval is going to be reading. In the right oval, we're going to put all of the people who are taking only science, and then in the middle is going to be the people who are taking both. That middle, just so you know, actually there's a symbol for it. We use this intersection symbol, so it would look like this, and we'll talk more about this later, but the middle section is math and science. That symbol stands for intersection. It stands for the word and. Okay, so in this case, it would be, this middle would be R and S. Right in there. Okay, so let's go through the people who are taking only reading. Let's see, Bob. Yes, Bob is taking only reading, so Bob goes in here. Elizabeth is taking only reading. Now, I realize she's also taking math, but we're only looking at reading and science right now. So Elizabeth would go in here. Kurt, he's good to go. Liza, that's good. Max in this one. Nathan and Olive. So all of those people do not have overlap with science. Now look at science. We've got Alice. We've got David, Frank, George, Helen, Ivan, and Jane. And what we notice here is that there are no students who are taking both science and reading. So we would say in this case, yes, those two events are mutually exclusive because no names in the overlap. No names in the intersection. Okay, and finally one more. Let's take a look at math and reading. So in the first one, I'm going to do math, and the second one, I'm going to do reading. Let's see, I'll use green for this one. So math and reading, that would be, this is M and R. Get used to that symbol. We're going to use that quite a lot in here. So the students who are taking only math, now we're looking at those first and last column, that would be Alice. Bob is out because he's also in reading. We can go ahead and put him in the middle. Kelvin is in the only math. David is in the only math, and Elizabeth, I'm going to put her in the middle because she is taking both. Okay, now only reading, that would be Kurt, Liza, Max, Nathan, and Olive. So are these events mutually exclusive? The answer would be no, because we see overlap. It is possible for students to take both math and reading. Okay, so I'm going to have you practice this on your own. Now, obviously, it's going to be very tempting to just not pause the video and just have me go through it and tell you the answers, but I'm going to ask you to please pause the video and try the rest of this worksheet. So all the questions are simply asking you, are they mutually exclusive or not? Now, you don't have Venn diagrams, but you're just going to think through, could these two events happen at the same time? Could they happen simultaneously? So you've got 2 questions there on the front, and you have a few more on the back. Pause the video now and try those. And then when you're finished, unpause and I'll go through the solutions with you. Okay, hopefully you were honest and actually tried them. The first one, toss a coin and get heads, toss a coin and get tails. Those events cannot happen at the same time. So this would be mutually exclusive. There is no overlap. You either get a head or a tail. You can't have both. Roll a dice and get a 1. Roll a dice and get a 6. Now we're looking at this as in one roll. Can you get a 1 and a 6 on one roll? The answer is no. There's no overlap. So this would again be mutually exclusive. Okay, going on to number 3 on the back. Roll a dice and get a 2. Roll a dice and get an even number. Could you get both 2 and an even number on the same roll? Of course, if you got 2, that's an even number. So this is not mutually exclusive. Number 4, a bag contains 4 yellow balls and 3 blue balls. A ball is drawn from it. Event A, you get a yellow ball. Event B, you get a blue ball. You are only pulling out one of these items from the bag. So can it be both yellow and blue at the same time? No. So this is mutually exclusive. I'm just going to abbreviate with ME, mutually exclusive. One student is selected. John is selected. Peter is selected. If only one student is being selected, it can't be both John and Peter. So this would be mutually exclusive. There is no overlap there. Number 6, a card is drawn from a deck of standard playing cards. A spade is drawn, a heart is drawn. There are no spades that are also hearts, and there are no hearts that are also spades. So this would be mutually exclusive. And number 7, a card is drawn from a deck of standard playing cards. A heart is drawn, a king is drawn. Are there any hearts that are kings? Yes. Are there any kings that are hearts? Yes. So this would be not mutually exclusive. So mutually exclusive events, again, are events that cannot happen at the same time.